Hello, are you interested in using a CT scanner for your research but aren't sure how it works or what's involved? Don't worry, because today I'm going to show you the process starting from setting a sample, running scans, and getting results. I'm Angela Criswell, and today I'm going to demonstrate our most versatile microCT scanner. So this is the CT Lab HX instrument. Behind this barrier here is where the X-ray source is. We can insert filters here. You would use a different filter when you perhaps change energy. We have a range of filters. For example, for high energy, then you might want to use an aluminum filter. You might also choose a filter based on your sample type. So let's say we were imaging a battery. You might want to use a thicker copper filter. This is where the sample stage is, so it has rotation and some translation. Downstream of the sample position, we have the area detector, and that's where the X-ray photons will be measured. Now, you'll notice that the detector is quite far away from the sample position, and that's because this is a very versatile instrument. It uses cone beam geometry, and in that case, we can measure data for very small samples like this drill core, and you can measure very large samples, say up to 200 millimeters, and still get good magnification by moving the detector far away. So to load this sample, I've simply taped it to a post, and then we're going to put it in at the sample position next. Simply just put the post in, then I tighten it here to the sample rotation with this screw. Our next step then is going to be to close the door, and that will activate the interlocks so that we can turn X-rays on for our experiment. We're going to come over to the instrument control software to collect our data. To set the scan conditions, we're going to use the software interface. But before we start a scan, we have to center the sample. So to do that, we're going to turn X-rays on, and then we see a radiograph of the sample at 2D. So we can actually see the crack that is in the middle of this sample, and so we definitely want to investigate that. So we're going to center this just by clicking. Because our scan is going to be collected with 360-degree rotation, we'll want to center 90 degrees relative as well. Now we're ready to go to collect the scan. I'm going to turn the X-rays off, and I'm going to select a continuous scan. We're going to do this fairly quickly. So we're going to choose a quick standard 2-minute scan for this. One of the great things about this instrument is it's quite versatile. So we can put a small drill core like this sample inside, but we can have a sample up to 200 millimeters and image it within this instrument. And you can do it quickly or take your time to do a very careful scan. Makes it a very powerful instrument. So now the scan is finished and it's returning the sample stage to 0 degrees. And what you'll see in the bottom left is that reconstruction is started. So now our scan is finished, the reconstruction is finished, and we can start to review the results. I'm gonna open this in an interactive mode. So now we can zoom in and we can see this crack in this drill core, and we see several 2D cross sections. So what we can do next with this image, if we wanted to do some quantitative analyses, is that we can import it into another piece of software. So here is the drill core that's been loaded in the software. So we have a 3D volume view as well as our 2D cross sections. And we can look closely at the crack. So we see in the bottom left view, we see the crack that's interrogated here. What we can also do is we can segment the core portion from the void portion. And then if we want to calculate something specifically for that crack, what we can do is we can select the largest void, which should be the crack because it consumes the most voxels. And then we can look at a thickness distribution. And that's what's shown here. So I'm going to turn this off, and we can zoom in here and have a look at this thickness mesh. So the areas that are thinnest are the purple, and the areas that are thicker are green to yellow. And we see that this crack extends into the core above and below the crack. So that's what we can do with the CT Lab HX instrument in terms of collecting data and looking at a scan and analyzing the results. So now you've seen the entire process and you may have more questions. To follow up, reach out to us to talk to an expert or you can email us at imaging@rigaku.com. Just remember that we're here to help you. Thanks for watching.